We have to find P and Q, and we find P and Q. These are P and Q. P is this much. Um, by integrating, P is this and this. Okay, this is the displacement. This is displacement. This thing versus time relation, and the graph is this. Okay, the graph is this. Acha, if you notice, the graph starts at here and goes up till here, then comes down, then goes up. The question says find the point. After that, the question says find the when it is at instantaneously at rest. When is it? That means instantaneous. That means velocity is zero. Okay, velocity is zero means it changes direction. Changes direction because the velocity is becoming. It was positive first, then it became negative. Okay, then that means it is changing direction. It was going like this, then it started coming back. And we find the velocity zero at two places. He says the velocity is zero at 1 and 3. But then the next question says, and I draw the graph and I find it is zero at 1 and 3. This is 1. At 1, the slope is 0. At 3, the slope is 0. So, and it is changing direction. So it was here the velocity was positive. Here the velocity is negative. Here again the velocity became positive. So this is how distance becomes. When they ask you distance, this is you'll have to see the direction because distance doesn't depend on is not negative or positive. So in the next part, he says find the distance traveled. Now 0 to 4. So where in at 1 second now it was going positive, then it became negative. Then again at 3 seconds after it became positive, at 3 seconds, it started moving here. So first it was going like this. At 1 second, t is equal to 1, it changed direction. Then at 3 seconds, it again changed direction. But the displacement is the coordinate, but distance you have to add all this. So that's what we have to do. If you notice the graph, if he's asking you distance from here to here, from it is moving from this point is actually it got hidden. It is 0, 1. So this is 0, 1. So 1 this position, then 5 position. So displacement of 4. A displacement of 4. Then it goes from here to here, but it in the opposite direction. The displacement is still is reducing, but the distance is 4 because it's going from 5 to 1. So, and again, it starts moving in this direction. So if you see the displacement time curve, first it moves plus 4, then it moves minus 4, but you have to take the modulus because you have to consider distance, and then and again it goes. So actually the answer is 12. But if you see the velocity time graph, then you do this is negative displacement. This is positive displacement. Like this distance, this area. Then this area is negative. Then again this is positive. So we do v dt 0 to 1. This is part is positive. Then 1 to 3 v dt is negative. So we will have to take the modulus, and 3 to 1 4 so this is a you just don't put values in s as t is equal to 0 and t is equal to 4 and see the difference. No, you'll have to see the graph. So this is what he's doing. He's finding um the solution. Yeah, he's doing this 0 to 1, 1 to 3, v to d, or he's saying 0 to 1 it is 4, then 1 to 3 it is minus 4, but you take positive 4, and then from 3 to 4 it is another 4. So these three fours you add, you get 12. Or you do integration, definite integration, and get 12. But you don't just don't think that I will plug in t is equal to 0 and t is equal to 4 in displacement. That will all give you the displacement, that won't give you the distance. Understood this concept?